Hello, in this lecture I find out the area of the green shape. In the drawing, we have triangle ABC. Triangle ABC is a right angle. This angle is a right angle. You know that side AB of triangle ABC equals to 6 units in its length. Side AC equals to 8 units in its length. Inside this triangle ABC, we have those two identical circles. And our task is to find out the area of this green shape. So first of all, we find out the length of the hypotenuse BC of triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, in the right triangle ABC, is that the square of the hypotenuse is BC squared and it must be equal to AB squared plus AC squared. And again, the right triangle ABC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, equals to AB squared plus AC squared. BC is the missing hypotenuse, so let us it is. It is BC squared equals to AB squared. AB is 6, therefore AB squared is 6 squared, that is 36, plus AC squared. AC is 8, so AC squared is 8 squared, that is 64. So instead we found out that BC squared equals to 36 plus 64. 36 plus 64 is 100. So BC squared equals to 100. Here we take out of this equation and find again that BC equals to the square of 100, that is 10. So the length of the hypotenuse BC in the right triangle ABC is equals to 10 units. BC equals to 10. What is the area of the right triangle ABC? You know that the area of any triangle equals to the base of the triangle times the height over 2. So the area of this triangle ABC will be equal to the base AB times the height AC over 2. And again, the area of the right triangle ABC equals to the base AB times the height AC over 2. The base AB is 6 times the height AC is 8 over 2. So total the right triangle ABC equals to 6 times 8 over 2. 6 times 8 is 48. 48 over 2 is 24. In total, we found out that the area of this big right triangle ABC is equal to 24 square units in its size. In the next step, when we find the center of this circle, this point is point P. When we find the center of this circle, this point is point Q. When we find the point of tendency of tangent BC with this circle, this point is point L. Likewise, when we find the point of tendency of tangent BC with this circle, this point is point Q. When we find the point of tendency of tangent AC with this circle, this point is point T. And finally, when we find the point of tendency of tangent AB with this circle, this point is point K. In the next step, we join points P and N together by straight line. When we find the radius of this, those two circles, SX. Of course, they have the same ODI because they are identical. So join points P and N together by straight line. Point P is the center of the circle, point N is the point of the circle itself. Therefore, PN is the radius of the circle that we define as X. Here we can implement rule 1 because here the radius PL is equals to X. The radius PL is drawn to point L. That is the point of tendency of tangent BC with this circle. And whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius LP. If BC is perpendicular to LP, this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. Likewise, we join points Q here we change the point of tendency, we define the point of tendency of tangent BC with this circle. This point is point H. We have 2 times Q, so change the point of tendency of tangent BC with this small circle. This point is point H. And join points Q and N together by straight line. QN is of course also on the radius of this circle, it equals to X. According to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Those two circles that touch each other at this point. This is the touching point, so when we find the touching point, this point is point M. in the next step, we join points, we join the centers of those two circles by a straight line. That is to say, we join the center of this circle that is at point P, the center of the circle that is at point Q. So we join points P and Q together by a straight line. Those two small circles have an external match between them at point M. That is to say, they touch each other externally at this point M. Whenever you have an external match between two circles, you can implement rule 10. So, repeat quickly on rule 10. According to rule 10, if two circles touch each other externally, then the straight line that connects their centers together passes through their touching point. Those two circles touch each other externally at point P. Point O is the center of this circle. Point M is is the center of this circle. The straight line that connects their centers together is of course the straight line OM. And according to this rule 10, the straight line OM that connects their centers together must pass for their touching point, that is point P. Again, according to this rule 10, the straight line that connects the straight line OM that connects their centers together must pass for point P, that is their touching point. Or OPM is one straight line. Again, OPM is one straight line according to this rule 10. So we can actually implement rule 10 in our drawing, because in our drawing those two circles touch each other externally at point M. The straight line, the center of this circle is at point P. The center of this circle is at point Q. And the straight line that connects the centers together is of course the straight line PQ. And according to rule 10, the straight line PQ must pass from point M, that is their touching point. Again, according to rule 10, the straight line PQ that connects their centers together, the straight line PQ that connects their centers together must pass for their touching point, that is point M. Or PMQ is one straight line. Again, PMQ is one straight line according to rule 10. Therefore, if PMQ is one straight line, it means that PQ will be equal to PM plus MQ. Again, PQ in total will be equal to PM plus MQ, because PMQ is one straight line. PM is the radius of this circle, that equals to X. Likewise, QM is the radius of this circle, that is also equals to X. And therefore PQ in total equals to X plus X, that is 2X. So PQ equals to 2X. Line 7 PQ equals to 2X according to rule 10. In the next step, we'll do a construction, that is to say, from point M, the point of tendency of those two circles with each other. So from point M, we draw perpendicular on BC. Again, from point M, we draw perpendicular on BC. So actually, This angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point M and BC. This point is point S. It is very easy to see from the drawing that SM is a tangent. It is a common tangent of those two circles. SM is a tangent to this circle at point M. SM is also tangent to this circle at point M also. So according to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. If we focus on this circle, the radius PM that equals to x, the radius PM is drawn to point M, that is the point of tendency of tangent SM in this circle. Whenever your radius is drawn to the point of tendency, then tangent SM will be perpendicular to the radius MP. If SM is perpendicular to PM, then this angle equals to 90 degrees according to rule 1. Likewise, SM is a tangent to this circle at point M. And according to rule 1, this angle equals to 90 degrees. So in this small polynomial QMSH, we have 1, 2, 3 right angles. The sum of 3 right angles is 230 degrees. 230 degrees plus the size of this 4 missing angle, the total must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this 4 missing angle must be equal to 90 degrees in its size. So inside quadrilateral QMSH we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this rectangle if not a square, so we have to quadrilateral QMSH is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle QMSH, side QM is equal to the opposite side edge S, but QM is x, therefore the opposite side SH must be also equal to x units in its length. And for the other PMSL, we have 1, 2, 3 rectangles, therefore this 4 missing angle must be equal to 90 degrees in its size. And therefore, for the other MPLS is rectangle because it has 4 rectangles. So what is normally is a rectangle. You know that the opposite sides of a rectangle are equal to each other. So in rectangle PMSL, side PM is equal to the opposite side LS, but PM is x, therefore the opposite side LS also equals to x units in its length. So we found out that LH equals to x plus x, that is 2x. So LH equals to 2x units in its length. Write it down. LH equals to 2x. This is the big quadrilateral PQHL. The big quadrilateral PQHL is 1, 2, 3, 4 right angles, and the quadrilateral PQLH is a rectangle. So write it down. We should find out that the big quadrilateral PQLH is a rectangle because it has 4 right angles. So in the next step, we join points A and Q together by a straight line. And we join points A and P together by a straight line. By doing this construction, we create a triangle APQ. This is triangle APQ. So, in the next step, I'll copy this rectangle PQHL in another page, and we'll analyze this triangle APQ. Actually, we'll find out the area of this triangle APQ. Q edge is the radius of the circle that equals to x. Those triangles are right angles according to rule 1. Likewise, we have here the radius PL is also equals to x units in its length. This angle equals to 90 degrees. This angle is also equal to 90 degrees in its size according to rule 1. We have PQ. That is the straight line that connects the centers together. Passes for point N according to rule 10. We already found out that PQ equals to 2x. PQ equals to 2x. PQ is the base of triangle APQ. Again, PQ is the base of this triangle APQ. Is equals to 2x. PQ is equals to 2x. In the next step, we find out the height of triangle ABC. And again, we find out the height of this triangle ABC. So, from point A, we will go perpendicular on BC. Again, from point A, we will go perpendicular on BC, and the perpendicular will be the height of triangle ABC. It will be the height to the base of triangle ABC. That is to say, the area of triangle ABC will be equal to the base BC times the height over 2. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We draw perpendicular from point A to BC. So must be a right angle, those two angles. We define the touching point of the perpendicular from point A and BC. This point is point T. So actually, AT is the height to the base of triangle ABC. So we define AT equals to H. AT perpendicular AT is the height to the base of triangle ABC, and it is equals to H according to our definition. In the next time we focus on this rectangle PQHL. We already found out that for the other PQHL is a rectangle. Yeah. For the other one, PQLH is a rectangle. According to what we already found out. And again, for the other PQHL is a rectangle. The opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are parallel to each other. So rectangle PQLH, side LH is parallel to side PQ. Those two sides are parallel to each other. Those two angles are defined as corresponding angles, and they are located between the parallels PQ and LH, and therefore they are equal to each other according to the rule that says that corresponding angles between parallels are equal to each other. But this is a right angle, therefore this angle must be a right angle according to the rule that I mentioned. So this angle equals to 90 degrees in its size. Likewise, those two angles are defined as corresponding angles, and are located between the parallels PQ and LH, and therefore they are equal to each other. For this angle equals to 90 degrees, and therefore this missing angle must be equal to 90 degrees inside according to the rule that I mentioned. So, we focus on this point. We define this point as point G. The height AT is definitely a straight line. So if you focus on the left side of the straight line 18.g, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the left side of 18.g, we have 90 degrees, plus the missing angle, so that must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees inside, according to rule 3. The sum of the angles on the right side of the straight line 18.g must be equal to 180 degrees, and therefore this missing angle must be equal to 90 degrees in its side, according to rule 3. This is the small polynomial PGTL. The small polynomial PGTL, we have 1, 2, 3 angles, and therefore this missing angle must be equal to 90 degrees in its side. So it is left there because it has 4 attackers. Likewise, this quadrant GQHT, we have 1, 2, 3 attackers, and therefore this 4 pieces again must be equal to 90 in size, and therefore quadrant GQHT is a rectangle because it has 4 rectangles. Those two shapes are both rectangles. We know that the opposite sides of a rectangle are equal to each other. So in rectangle PGTL, side PL is equal to the opposite side GT. Again, PL, rectangle PGTL, side PL is equal to the opposite side GT. But PL is x, therefore the opposite side TG must be also equal to x units in its turn. Only to know that the opposite sides of rectangle are equal to each other. So, what is the length of AG? AG is actually the height to the base of triangle APQ. Again, AG is the height to the base of this triangle APQ. Because it creates 90 degrees with the base PQ. What is the length of the height AG? The height AG equals to AT minus GT. So write it down. The height AG in total it is equal to AT minus GT. AT minus GT equals to AG. AT is H. AT equals to H according to our definition. AT equals to H. It is the height of the big triangle. ABC minus GT. We just found out that GT equals to X. So in total we found out that the height of the small triangle APQ, the height AG is equals to H minus X units in its length. H minus X units in its length. Now it is very easy to see, to find out we have this small triangle APQ. There the small triangle APQ will be equal to the base PQ. What is the length of the base PQ? We already found out that PQ equals to 2x. PQ equals to 2x, so the base of triangle PHQ equals to 2x units in its length. The height of triangle APQ equals to H minus X, so the height that is the base that is 2x times the height that is H minus X equals to this triangle APQ. What is the value of H? In order to find out the value of H, that is the height of the big triangle ABC, we will use the formula that says that the of m triangle equals to the base times the height over 2. So there of the big triangle ABC equals to 24 square units in size. The triangle ABC is equal to the base of the triangle times the height over 2. So the triangle ABC equals to the base BC times the height to the base. The height to the base is 80 again. The height to the base BC is 80 and this equals to H. So it's 80. That is 80 over 2. BC is 10. Only found out that BC equals to 10 units in its length. So BC is 10. The height 80 is H. Only the definition 80 equals to H. 8 equals to h divided by 2. So in total we found out that the error triangle ABC equals to 10h over 2. But we only found out that the error triangle ABC equals to 24. So we substitute the error triangle ABC by 24. And we get that the error triangle ABC that is 24 is equal to 10h over 2. 10 over 2 is 5, so this expression equals to 5h so now we found out that 24 equals to 5h. Here we divide this equation by 5, and finally we get that h, that is the area of the big triangle ABC, that is the height to the base BC, h in total equals to 24 over 5, that is 4.8 units in itself. So if we found out that the height to the base BC of the big triangle ABC equals to 4.8 units in its length. So the height to the small triangle, the height to the base of the small triangle PQ equals to h minus x. So h minus x, h is 4.8, so h minus x is 4.8 minus x. In total, we found out that the area of this, the height of this small triangle PQ is equal to h minus x, that is 4.8 minus x. So in total, the area of this triangle APQ is equal to the base of the triangle that is PQ times the height to the base that is AG, and AG equals to 4.8 minus x over 2. Okay, again, the area of this triangle APQ equals to the base PQ times the height that is 4.8 minus x over 2. And again, the area of the small triangle equals to the base PQ times the height to the base PQ, that is 4.8 minus x divided by 2. We already found out that the base PQ equals to 2x. So we substitute the base PQ by 2x. So now the small triangle PQ in total it is equals to PQ, that is 2x times 4.8 minus x divided by 2. And again, in total we should found out that the area of this small triangle APQ equals to 2x times 4.8 minus x over 2. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. And we left only with x times 4.8 minus x. So we'll open the brackets of this expression. X times 4.8 is 4.8x, and x times minus x is minus x squared. So in total, we actually found out that the area of this small triangle APQ is equal to 4.x minus x squared units in its size. The area of this triangle APQ equals to 4.x minus x squared units in its size. So, in the next step, we will join points B and P together by straight line. We join points C and Q together by straight line. We define the point of tendency of tangent AB with this circle. This point is point Z. And we join points P and Z together by straight line. PZ is of course the radius of the circle that is equals to x. And according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we define the point of tendency of tangent AC with this circle. This point is point N. We join points Q and N together by straight line. QN is of course the radius of the circle is equals to x. This angle equals to 90 degrees, and this angle also equals to 90 degrees according to the sum rule 1. What is the area of the big right triangle ABC? What is the area of this big right triangle ABC? We of course found out that the area of ABC equals to 24 square units in size. But the big right triangle ABC consists of 6 shapes. It consists of those two right triangles. That is to say, it consists. It is not right triangle. It consists of triangle APB plus triangle AQC. This is those two right triangles. Likewise, it consists of those two right triangles. In total, it is 4. And also consists of this right triangle PQ and H. And finally, it consists of this triangle APQ, and we found out that the triangle APQ equals to 4.8 x minus x squared in size. So in total, it is very clear that the area of triangle ABC must be equal to the sum of the areas of the 6 shapes that it consists of. Again, the area of triangle ABC must be equal to the sum of the areas of the 6 shapes that it consists of. So we calculate the area of each shape. We add the areas of the 6 shapes together, and this will be the area of triangle ABC that we know that is equals to 24 square units in size. But by doing this operation, we will express the area of triangle ABC in terms of x. We get one equation that says that the area of triangle ABC is equals to 24. It is equals to some expression with the variable x. So we have one equation with one variable that is x. We are able to solve one equation with one variable with x. This way we find out the value of x. X is the radius of the circle, and the area of the green shape will be equal to the area of the big triangle ABC minus the areas of those two small circles. The area of those two small circles will be equal to 2 times the area of one circle, because they are identical, therefore they have the same area. So the area of the green shape in total equals to the area of the big triangle ABC minus the area of those two circles. The area of each circle is pi x squared, and therefore the area of those two circles will be equal to 2 times pi x squared. So the area of the big triangle ABC, that is 24, minus 2 pi x squared will be equal to the area of the green shape. Okay, so somebody mentioned the big triangle ABC equals to the sum of the areas of the 6 shapes that it consists of. So the area of triangle ABC in total is equal to the area of this triangle APP. The area of this triangle APP plus the area of this triangle AQC. The area of this big triangle AQC. Plus the area of this small right triangle PLB. This is right triangle PLB. Plus the area of this small right triangle QHC. Plus the area of this rectangle PQLH. Rectangle PQLH is a rectangle. A quadrilateral PQLH is a rectangle according to what we already found out. So plus the area of this rectangle PQLH. Plus the area of this triangle APQ that we already found out that this triangle APQ is equal to 4.x minus x squared in size. Again, the area of triangle ABC must be equal to the sum of the areas of the 6 shapes that it consists of. That is to say, the area of triangle ABC in total must be equal to the area of the first shape that it consists of, that is the area of triangle ABP, plus the area of the second shape, that is the area of triangle AQC, plus the area of the third shape, that is the triangle PLB, plus the area of the fourth shape, that is the area of the right triangle QHC, plus the area of the fifth shape, that is the area of rectangle PQLH, plus the area of the sixth shape, that is the triangle APQ. So we find out the area of each shape separately, and then we get the six areas of the six shapes together, and this will be the area of triangle ABC. This is equals to 24. In this here in the other side of the equation, we have the area of triangle ABC in terms of x. And again, that the area of triangle ABC is equals to 24 square inside equals to some expression in terms of x. So we have one equation, one variable. Definitely can solve one equation with one variable. This way we find out the value of x, that is the radius of the circle, and this way we get that the other shape equals to the outer ABC, the right ABC, minus the of those two small shapes. The only missing variable is that is the radius of the circle, that is x. And we find out the radius of the circle by solving this equation. 24 equals to this expression, that is the expression in terms of x. So we can find out that we know that the outer ABC equals to 24 square units in its size, and it equals to this triangle APB. The outer APB equals to the base AB. The base AB is 6 according to what is given us in question. Pn is x. So the outer ABP equals to the base AB, that is 6, times the height NP, that is x, over 2. AB is 6 times the height edge over 2, so it is 6x over 2. APB equals to 6x over 2 plus the area of this triangle AQC. The area of this triangle AQC equals to the base AC, that is 8, times the height NQ, that is x over 2. So in total it is equals to 8x over 2. Plus the area of the triangle, the right triangle PLB. The other right triangle PLB equals to the base BL times the height x over 2. So total this right triangle PLB equals to BL times x over 2 plus the area of the right triangle QHC. What is the area of this right triangle QHC? Equals to the base edge C times the height x over 2. It again the area of this triangle, the right triangle QHC equals to the base edge C times the height x over 2. So it is HC times x over 2. Plus the area of this rectangle PQHL. The area of a rectangle equals to the base of the rectangle to the length of the rectangle times the width. We already found out that the length PQ is x, and PQ is x. So the length, that is 2x, times the width, that is x, that is x. So total, the area of this rectangle PLHQ equals to the length that is 2x times the width, that is x. So it is 2x times x. So PQLH equals to 2x times x, is actually 2x squared. Plus the area of this triangle PAPQ, we found out that the area of triangle APQ equals to 4.x minus x units, 4.x minus x squared units. Again, the area of this triangle APQ equals to 4.8 minus x 4.x minus x squared in size. And again, there on this side AP2 equals to 4.x minus x squared in size. So in total, this big expression, it must be equal to 24. That is the rectangle ABC. The rectangle ABC. You can see that in the other side of this side of the equation, all the only variable that we have here is x. The problem is if those two expressions, we have to turn those two expressions only that they have to have only in terms of x. We have to turn those be lx over 2 plus hcx over 2. We have to turn them that they will have only the only variable that they will have is x. Okay. So 24 equals to 6 over 6x over 2 is 3x plus 8x over 2 is 4x. So here we have blx over 2 plus hcx over 2. We take x over 2 as a common factor from those two expressions. So what is left from this expression after we took from it x over 2 as a common factor? What is left is actually BL. And what is left from this expression after we took from it x over 2 is a common factor? What is left is actually hc plus 2x times x is 2x squared plus 4.8x times x squared. So 24 equals to 3x plus 4x is 7x. And we have here x over 2. What is the value of BL plus HC? What is the value of BL plus HC? Actually, BL plus HC will be equal to BC minus TH. But again, it is very easy to see from the drawing that BL plus HC equals to BC plus TH. If you take from BC this part here, we'll get BL plus H. Again, if you take from BC this part that is TH, we'll get what is left is BL plus HC. So BL plus HC, BL plus HC equals to BC minus TH. BC minus TH. BC is 10, BC is 10, and we only found out that TH, again, it is, if you take from BC this part LH, what is left is BL plus HC. So it is BC minus LH. BC minus LH. So BL plus HC equals to BC minus LH. Again, if you take from BC this part LH, what is left? What is left is BL plus HC. So therefore BL plus HC equals to BC minus LH. So BL plus HC equals to BC, that is 10. What is the value of LH? The opposite sides of rectangle PQ LH are equal to each other. Again, the opposite sides of rectangle PQ HL are equal to each other. But we already found out that PQ equals to 2x, and therefore the opposite side LH must be equal to 2x units in its length. So H equals to 2x. H equals to 2x. So total BL plus HC equals to BC, that is 10, minus LH, that is 2x. So total we found out that BL plus HC equals to 10 minus 2x units in its length. Again, BL plus HC equals to 10 minus 2x. So we can substitute BL plus HC. Can substitute BL plus HC in this equation by 10 minus 2x. Now, in this number equation, we have only one variable that is missing. It is very easy to solve one equation with one variable. Okay? In this way, by doing this operation, you actually found out the value of x, that is the only missing variable, that is the radius of the circle, and this way actually finished with the question. Because the area of the green shape equals to the area of the ABC minus the area of those two small circles, and the area of those two small circles equals to x, and the area of the circle equals to pi x squared, and x will be found out by solving this equation. This way actually finish to answer the question. So the only thing that is left to do is to find out the value of x by solving this long equation. So you have here plus 2x squared plus 48 plus 4.x plus x squared. So 24 equals to 7x plus x over 2 times x minus 2x. Here we'll open the brackets of this expression. We have x over 2 times 10. X over 2 times 10 is 5x, because 10 over 2 is 5. So in total x over 2 times 10 is 5x. Minus x over 2 plus x over 2 times minus 2x, it is minus 2x squared over 2, that is minus x squared. Again, minus 2x squared over 2 is minus x squared, plus 2x squared, plus 4.x, minus x squared. So here we have minus x squared is minus 2x squared, and minus 2x squared plus 2x squared is 0. So those three expressions will get cancelled. And we're left only with 24 is equals to 7x plus 5x is 12x plus 4.x. So in total, we should find out that (24) equals to 12x plus 4.x. 12x plus 4.x is of course 16.x. It's 16.8x. So in total, we should find out that 24 equals to 16.8x. Here we divide this equation by 16.8, and finally we get that x, that is the radius that we are looking for, the radius of the circle, is equals to 24 over 6.8 units in its length. That is the radius of the small circles. So as I mentioned before, now it is very easy to see to find out the area of this green shape. What is the area of the green shape? The area of the green shape equals to they have the big right triangle ABC that we know that is equal to 24 square meters in size. Minus they have those two identical circles. So it is minus 2 times they have one circle, that is actually pi x squared. That is their penny circle. So if you found out that they have that we are looking for this question, that is they have this green shape in total is equal to they have the right line ABC minus they have the two circles, because they are identical, they have the same area, so it is 2 times the area of 1 square. What is the area of 1 square? It is pi x squared. So it was 2 times the area of 1 square, that is pi x squared. So it is total equals to 2 pi x squared. They have the big right triangle ABC, it is equals to 24 square units in its size, minus 2 pi times x squared. X is 24 over 16.8. Therefore, x squared will be equal to 24 over 6.8 squared. So total, the obligation equals to 24 minus 2 pi times 24 over 16.8 squared. So it is actually equal to 24 minus the value of this expression, and the value of this expression, it is equal to 12.822. So that the value of this expression is 12.822. 3. In total, thereof, the gain equals to 24 points, 12.823. 24 minus 12.823. In total, it is equal to 11.177 square meters in its size. So if you found out that there that we are looking for this question, that is there of this green shape, in total it is equal to 11.177 square meters in its size. So I finished to answer the question. In the next step, answer the lecture. Our task in this question is to find out of this green shape. So in the drawing, we have the right angle ABC. ABC is the right angle because this is a right angle. We know that side AB of the right angle ABC equals to 6 units in length, side AC equals to 8 units in length. The hypotenuse BC is the missing side. It is very easy to find out the value of the hypotenuse by implementing the Pythagoras theorem in this triangle ABC, right angle ABC. In addition, inside this right triangle, we have those two circles that are identical. And again, our task in this question was to find out the value of this green shape. So first of all, we implemented the Pythagoras theorem on this right angle ABC in order to find out the value of the hypotenuse BC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABC, it means that BC squared, that is the square of the hypotenuse, must be equal to AB squared plus AC squared. In the right triangle ABC, here by PT is the provision for Pythagoras theorem. So according to the Pythagoras theorem, in the right triangle ABC, BC squared, that is the square of the hypotenuse, equals to AB squared plus AC squared. BC is the missing side, so the missing hypotenuse of electricity, so it is BC squared equals to AB squared. AB is 6, therefore AB squared is 6 squared, that is 36, plus AC squared, AC is 8, so AC squared is 8 squared, that is 64. So in total, BC squared equals to 36 plus 64, that is 100. BC squared equals to 100, here we took out 100 in the equation, and we found out that BC, the missing hypotenuse BC equals to the square root of 100, that is 10. So the value of the hypotenuse BC is equals to 10 units in its length. In the next step, we found out the right triangle ABC. The area of any triangle equals to the base of the triangle times the height over 2. We choose the base SAB times the height is AC. AC is the height because it's right 90 degrees with the base AB. So again, it is the base AB times the height AC over 2. The right triangle ABC equals to the base AB times the height AC over 2. AB is 6, AC is 8 over 2. 6 times 8 is 48 over 2. 48 over 2 is 24. So in total, if you found out the area of this right triangle ABC is equal to 24 square meters in its size. We can find out the right triangle ABC in the different method. Here we choose the base of triangle ABC is AB and the height is AC. But you can choose the base of triangle ABC as BC. So if the base is BC, then the height will be 9 cm is perpendicular to BC over 2. So triangle ABC equals to the base BC times the height to the base BC over 2. To define the height to the base, this perpendicular as h. So it is BC times the height h over 2. So we have a different method to find out the triangle ABC. It is equals to the base BC times the height to the base BC, this is h over 2. So the triangle ABC equals to the base BC times the height. The height is 80 over 2. Yeah, this is the base BC times the height 80 over 2. The height 80 creates 90 degrees with the base BC. And we find the height 80 is h. So total the triangle ABC equals to the base BC times the height to the base 80 over 2. So we found out that BC equals to 10. The base BC equals to 10 times the height 80. We define the height 80 is h. So it is the base BC that is 10 times the height 80 that is h over 2. So total the area of triangle ABC equals to 10 h over 2. 10 over 2 is 5. So this expression equals to in total to 5h. But we already found out that the triangle ABC equals to 24. So we can substitute the triangle ABC by 24 and we get that 24 equals to 5h. Here we divided this equation by 5 and found out that the height 80 is equals to h is equal to 24 over 5. 24 over 5 is 4.8. So the height to the base BC 80 is equals to h is equals to 4.8 units in its length. So in the next step, we define the center of this whole circle, this point as point P. We find the center of this circle as Q, this point. We define the point of tendency of tangent BC with this circle, this point as point N. We define the point of tendency of tangent BC with this circle, this point as point H. We define the point of tendency of tangent AB with this circle, this point as point K. We define the point of tendency of tangent AC with this circle, this point is point T. We define the radius of this circle X, and because of the fact that they are identical, they have also the same radii. Then we join points P and L together by side line. Point P is the center of the circle, point L is the point of the circle itself, therefore PL is the radius of the circle is equals to X. The radius PL is equals to X, the radius PL is bound to point L, that is the point of tendency of the BC with this circle. Whenever the radius that is bound to the point of tendency, then tangent BC will be perpendicular to the radius LP. If BC is perpendicular to LP, this angle equals to 90 degrees, this angle also equals to 90 degrees, we form it all one. Likewise, we join points Q and H together by a straight line. QH is the radius of this circle. It equals to X. This angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the sum all 1. We define the touching point between those two circles. This point is point M. Then from point M, that is the touching point of the two circles, we do perpendicular on BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to all 1. Again, this angle equals to 90 degrees, this angle equals to 90 degrees, according to our construction. go from point A, we go perpendicular to BC, and therefore those two angles are right angles according to our construction. We define the touching point for point M and BC. This point is point S. Okay. So when doing this construction, we created this small quadrilateral PMSL. So what is the definition of SM? SM is a common tangent that belongs to both circles. SM is tangent to this circle, and SM is tangent to this circle, but it is a common tangent. So we have the radius PM is equals to X is drawn to a point M, that is the point of tendency of tangent SM in this circle, and the radius that is drawn to the point of tendency, then tangent SM will be perpendicular to the radius MP. So if SM is perpendicular to MP, then this angle equals to 90 degrees in itself according to rule 1. So in the small quadrilateral PMSL, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, so 270 degrees plus the side of this 1 angle. In total must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. 60 degrees. And therefore this 1 angle must be equal to 90 degrees in its size. Likewise, SM is also tangent to this angle because it is a common tangent. And not repeat on the same explanation. This angle equals to 90 degrees according to rule 1. So in quadrilateral QMSH we have 1, 2, 3 angles, and therefore this 4 angle must be equal to 90 degrees in size. So this small quadrilateral here 4 angles, therefore it is a rectangle. Here this small quadrilateral also we have 4 angles, and therefore it is also a rectangle. But we know that the opposite sides of a rectangle are equal to each other. So in rectangle PMSL, side PM must be equal to the opposite side LS. But PM is X, the opposite side LS must be equal to X units in its length. Likewise, this small rectangle QMSH, side QM is equal to the opposite side SH. But QM is X, therefore the opposite side SH must be equal to X units in its length. Okay. So actually, if you focus on the big quadrilateral PQHL, we have in the big quadrilateral PQHL we have 1, 2, 3, 4 right angles, and the quadrilateral PQLH is a rectangle. Quadrilateral PQLH is a rectangle because it has 4 right angles. Okay. The next step we join points A and P together by straight line, we join points A and Q together by straight line. We join doing this construction together there, right triangle APQ. I copied this those two rectangles and the big rectangle in a new drawing here. So we already found out that quadrilateral PQHL is a rectangle, and this is triangle ABC. Actually, draw the eye to the base BC. Again, we draw the eye to the base BC. AT is the eye to the base. Why? Because it creates 90 degrees with the base BC. So AT is the eye to the base of triangle ABC. So we define the eye to the base AT as H. It equals to H. Okay. Again, this angle equals to 90 degrees, this angle also equals to 90 degrees according to our construction, because it is a height, so we do perpendicular. So, but then this construction, we can do the small quadrilateral PGTL. Quadrilateral PGTL, we have, actually, we know that the opposite sides of a rectangle are parallel to each other. So in rectangle PQAJ, side PQ is parallel to opposite side LH. Okay, and we have that those two angles are located between the parallel lines PQ and LH, and therefore they are equal to each other. But this angle equals to 90 degrees, and therefore this angle must be also equal to 90 degrees in its size. Okay, repeat again. In rectangle PQAJ, the opposite sides are parallel to each other. So PQ is parallel to LH. PQ is parallel to LH, and therefore those two corresponding angles are located between the parallel lines PQ and LH, and therefore they must be equal to each other. But this is a right angle, therefore this angle must be also right angle. Likewise, according to the sum rule, those two angles are defined as corresponding angles, and they are located between the parallel lines LH and PQ. Therefore, they must be equal to each other and their sizes. But this angle equals to 90 degrees, and therefore this angle must be equal to 90 degrees in its size. So AT is the height is definitely a straight line. If you focus on the left side of the straight line, AT is point G. Here the sum of the angles must be equal to 180 degrees in their sizes. For each angle we have on the right side of AT point G, we have this angle that is right angle, therefore this angle must be equal to 90 degrees in its size, according to all three. Likewise, in the left side of the straight line AT point G, this angle equals to 90 degrees, therefore this angle must be equal to 90 degrees in its size, according to all three. So actually, in total, we found out that for the other PG TL, we have 1, 2, we have actually 4 right angles. All the angles are right angles, and therefore it is a rectangle. So we know that the opposite sides of a rectangle are equal to each other. So in rectangle PGTN, side PN is equal to the opposite side GT, but PN is X, therefore the opposite side GT must be equal to X units in its length. Okay. The reason that we have to draw another drawing is because of the fact that when we draw from point A perpendicular to BC, it is not necessarily passes for their touching point. If from point A we go perpendicular on BC, it's not necessarily pass for their touching point. That's point M. So you can see from the drawing that is definitely the perpendicular AP, the perpendicular AT, that is the height, so the rest BC is definitely not passes for their touching point. So we have to do all the work from the beginning in order to prove that this is a rectangle. Okay, this is the reason that I draw another drawing to prove that for the other PGTL is a rectangle. So I finally found out that GT equals to X units in its length. So AT is the height to the base of the big triangle ABC, so we define the height AT as H. What is the length of AG? AG equals to AT minus GT. Again, AG in total equals to AT minus GT. Okay. Again, AG equals to AT minus GT. AG equals to AT minus GT. AT is H according to our definition. And just like I found out that GT equals to X. So in total, AG equals to H minus X units in itself. AG equals to H minus X units in itself. But we already found out that the height to the base BC of triangle ABC equals to 4.8 units in its length. Here. The height H to the base BC equals to 4.8 units in its length. So you can substitute H by 4.8, and therefore H minus X is 4.8 minus X. So in total we found out that the height of the small triangle PHQ to the base PG, to the height HT to the base PQ of the small triangle PAG is equal to 4.8 minus x units in its length. But the base, what is the base PQ? Well, we found out that PQ equals to 2x. So the base PQ is 2x, the height AG is 8 minus x, and therefore in total the area of triangle ABC equals to the base PQ that is 2x times the height PG that is 4.8 minus x divided by 2. And again in total the area of this triangle APQ is equal to the base PQ times the height AG over 2. The height of triangle APQ in total equals to the base PQ times the height to the base, it is AG, that is actually 4.8 on 6 over 2. PQ is 2x, we only found out that PQ is 2x. So substitute PQ for 2x. We have 2 in the numerator, 2 in the numerator, so in total the area of triangle APQ equals to x times 4.8 minus x. We open the brackets here. X plus 4, x times 4.8 is 4.x. X times minus x is minus x squared. So in total, we should find out that the area of this triangle APQ is equal to 4.x minus x units in its size. 4.8 minus x units in its size. In the next step, we join points P and B together by a straight line. We join points Q and C together by a straight line. We join points P and Z together by a straight line. PZ is of course the radius of the second is 1 to x, and AB is the point of tendency AB is the tangent to this circle, point Z. So point Z is the point of tendency of tangent AB with this circle. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join point Q and N together by a straight line. AC is tangent to the circle point N, therefore this angle equals to 90 degrees, this angle also equals to 90 degrees, according to rule 1. Qn is of course the radius of this circle is equal to x. So what is the area of triangle ABC? The area of triangle ABC must be equal to the sum of the 6 shapes that it consists of. The big triangle ABC consists of 6 shapes in total. This is the first shape that is triangle AQC, plus the second shape that is triangle APB, plus the third shape that is the right triangle PBC, plus the fourth shape that is the right triangle QHC, plus the fifth shape that is this rectangle PQLH, plus the sixth shape that is this triangle APQ. Again, the triangle ABC must be equal to the sum of the areas of the 6 shapes that it consists of. So the triangle ABC equals to the area of the first shape that it consists of, this triangle APB, plus the of this the second shape that it consists of, that is the of this triangle AQC, plus the of the third shape that it consists of, that is the triangle BLP. This entire triangle BLP, plus the of the fourth shape that it consists of, that is the of the triangle QHC. This is one QHC, plus the fifth shape that it consists of, that is the rectangle PQLH, plus the sixth shape that it consists of, that is the triangle APQ, plus the sixth shape that it consists of, that is the triangle APQ. So we have to find out the 5 shapes separately. We add the 6 areas together, and this way we will find out the area of triangle ABC in terms of x, We know that the rectangle ABC equals to 24. So 24 equals to some expression with x. In this way we find out the value of x, that is the radius of the circle. So 24 equals to the first shape that is consist of, this is the first shape. The shape equals to the base AB times the height NP over 2. AB is 6, the height NP is x over 2. So in total it is 6x over 2. Now the first shape equals to 6x over 2, so it's in size. Plus the second shape that it consists of, that is the area of this AQP. The area of this AQP equals to the base AC, that is 8, times the height NQ, that is x over 2. So in total it is 8x over 2. Now the second shape in total is equals to 8x over 2. Plus the third shape, that is the of this right triangle PBL. The PBL equals to the base BL times the height LP over 2. So it is BL times the height LP, that is x over 2. So it is BL times x over 2. The triangle BLP equals to BL times x over 2. Plus the area of the fourth shape that it consists of, that is the area of this right triangle QHC. The area of this right triangle QHC equals to the base HC times the height QH over 2. So it is HC times the height QH, that is x over 2. So it equals to HC times x over 2. The area of the fourth shape, that is the QHC equals to HC times x over 2. Plus the area of this rectangle PQLH. We found out that PQLH is a rectangle. It is a rectangle, so the area of a rectangle equals to the height, the length PQ times the width PL. So we found out that PQ equals to 2x, so the length PQ is 2x, times the width PL, that is x. So it is 2x times x. So the area of rectangle PQLH equals to the length, that is 2x, times the width, that is x. Plus the area of this triangle AP2, we found out that the area of this triangle APQ equals to 4x plus x squared, so it's in its size. And again, the area of the sixth shape, that is the area of triangle APQ, in total it equals to 4.8x plus x squared, so it's in its size. Again, the area of triangle ABC equals to 24, and it equals to 6 over x over 2 is 3x, plus 8x over 2 is 4x. Here BL times x over 2, plus HC times x over 2. Here we took a common factor of x over 2 out of those two expressions. So what is left from this expression after we took from it x over 2 is a common factor? What is left is it is BL. What is left from this expression after we took from it x over 2 is a common factor? What is left is actually HC plus 2x times x is 2x squared plus 4.x minus x squared. So 24 equals to 3x plus 4x, 3x plus 4x is 7x. You have x over 2. What is the value of BL plus HC? BL plus HC. It is very easy to see from the drawing that if you take from BC, if you take from the big side BC, this part LH, what is left? Those two parts, BL plus HC. Again, if you take from BC, this part LH, what is left is actually BL plus HC. Therefore, BL plus HC equals to BC minus LH. Again, BL plus HC equals to BC, that is 10, plus HL, that is 2x. So we found out that BL equals to 2x. So HC, BL plus HC equals to 10 plus 2x. So we found out that the length of rectangle PQHC equals to 2x. So the opposite sides of rectangle are equal to each other. So PQ equals to LH. PQ is 2x, and therefore LH also equals to 2x. So in total, BC minus LH equals to BC, that is 10, minus LH, that is 2x. So in total, BLH, BL plus H equals to 10 minus 2x. Plus 2x squared, and we have here 4.8x minus x squared. So 24 equals to 7x. Here we open the brackets of this expression. X over 2 times 10 is 5x. X over 2 minus 2x is minus x squared, plus 2x squared, plus 4.8x minus x squared. 7x plus 5x is 12x. Here we have minus x squared is minus 2x squared, and minus 2x squared plus 2x squared is 0. So in total, those three expressions will get cancelled, and we'll have only 4.8x. So in total, we should know that 24 equals to 12x plus 4.x. 12x plus 4.x is 16.8x. So 24 equals to 16.8x. Here we divided this equation by 16.8, and finally found out that x equals to 24 over 16.8, 24 over 16.8 units in its size. So we did all this hard work in order to find out the value of x. Okay. Now it is very easy to find out the area of this green shape. The area of this green shape must be equal to the area of the big right triangle ABC plus the area of those two circles. And again, the area of the green shape in total must be equal to the area of the big right triangle ABC plus the area of the two circles. Because of the fact that those two circles are identical, they must have also the same areas. So it is the area of one circle times 2. The area of one circle is pi x squared. Therefore, the area of the two circles must be equal to 2 times pi x squared. So in total, the area of the two circles must be equal to 2 pi x squared. Again, the area of the green shape equals to the area of the right triangle ABC minus the area of the two circles, that is 2 pi x squared. We already found out that the area of the right triangle ABC equals to 24 square units in size, minus the area of the two circles, that is 2 times pi x squared. X is 24 over 16.8, therefore x squared is 24 over 16.8 squared. So in total, the area of the green shape equals to 24 minus 2 pi times 24 over 16.8 squared. So it is 24, and the value of this expression, 24 times 2 pi times 24 over 16.8 squared, in total it equals to 12.823. 24 minus 12.823 equals to 11.177 square units in size. So in total, we found out that the area of this green shape, that is the area that we are looking for in this equation, is equal to 11.177 square units in size. Okay, thank you very much.